Server-based steel connection user. In this tutorial, I'm going to show you how to design the shear connection. It's beam to girder, okay, beam to girder with cold beam and stiffener plate shear connection. So that's a PDF file. That's a PDF file. I provide a link below in the description area. There's a link to download this PDF file. It's a working sheet to work with this tutorial. All right, so download it. Okay, move this out. Okay, look at this detail, right? So look at this detail. It's being together shear connection with end plate. Okay, uh, with end plate, 2x2 both with cold beam, and the red one is horizontal stiffener plate. Okay, so we start with look at that detail. We get started. Okay, so before everything, make sure you check the setting. It's American code and the imperial unit. Okay, so let's start. Okay, so it's shear connection. It's being together. All right, get the section. The girder section is 460 by 113. 460 Canadian section. 460 by 113. Okay. The beam section is 246. Beam section is 246. All right. So go to beam to girder. Go to beam to girder. The gap is 0.5. This I copy everything first. Okay. Code beam. Look at this highlight. Okay. Code beam depth 1.25. Correct. Yeah, this one is 1/4. The plate thickness is ½ inch. 0.5, and it's 2x2. 2x2. Okay. The gauge. What's the gauge? It's 3.5. 3.5. As this one is vertical is 1.75, and that one is 3. I believe it's 3. All right. So the detail they has weld this flange to end plate. Okay. This weld is not helping the shear resistance. All right. So we don't have option to provide these end plate to beam flange weld, but it won't help with the shear resistance. So we just leave it. Okay. So and that's it. I think we go to design load. We have strong AISC shear 33.75, weak AISC shear 4.5, and tensile actual tensile 16.88. All right, so we have 33.8. This one is 4.5, weak AISC. Tensile is minus 16.9. Update. Okay, we'll get a low input here. We find the ratio is 1.12. Let's go to design check. and the failure part is coat beam fracture rupture. Okay, so that we can wrap a coat beam part. Web buckling is okay, but coat beam fracture rupture and yeah, this part is failing. Okay, so that's why we need this horizontal red one, stiffener plate. This one end plate cover is not necessary, but we need this horizontal red one. Okay, so go to strengthen the coat beam part. Go to the general. Let's provide horizontal reinforcing stiffener plate at the coat beam web. Okay, we get this guy here. Go to here. The it's 3/8. That one is 3" That's correct. The width, this length we go for 4". Update, and the welding is 316. Welding is 316. So we bring it down to 0.82. All right. So we have this reinforcing stiffener plate, and go to this coat beam. There's no more. I think there still is. Okay, fracture. You see here, from 1.12, bring it down to 0.27. Okay, coat beam fracture rupture. So with the stiffener plate, we pass the design load. So go to calculation. These are all calculation. You can expand all of them. All right, plane. So that's being to girder end plate shear connection with coat beams and reinforcing horizontal stiffener plate. Okay, that's design load, shear, tensile, and weight x6. So that's this detail. That's plan view. That's a side view. That concludes our tutorial on the shear connection with coat beam and stiffener reinforcing plate. See you next time. Bye bye.